Hello everyone, good evening. Welcome back to your own YouTube channel Gate Wallah English. I hope everyone is doing great. So before moving further, everyone kindly comment that I am fully audible and visible to you all. Good evening Sarthak, Vishal, good evening Sushil. Okay. Happy Holi everyone, happy Holi. Great. I hope you must be enjoying with your loved ones. So happy Holi everyone. Festive season is going on and you all have to study. I think it's injustice to you all. Okay. So basically today we are going to move ahead with the remaining topics of precipitation. Okay. Two Maharashtrians are there. Okay. Great. Okay, so we'll move ahead and we'll cover very interesting topic today, which is none other than frequency of point rainfall. Okay, very interesting topic. And what things we have already covered. Let us have a quick recap, then we'll proceed. In the last class, I hope you all remember what we have discussed. In the last class, we have discussed, can you tell me, sir, what we have discussed quickly? Then we'll move ahead. Basically, we were dealing with average depth of precipitation. Okay. Sir, you told us about average depth of precipitation. Sir, we have to evaluate it so that we can multiply it by catchment area and get the volume of rainfall. Okay. Then three methods we have discussed yesterday. I hope you all remember it. The first one was your arithmetic mean method, which was the least accurate, least reliable. And this was the basic formula. Then sir, Thyssen polygon was there, which was better, also known as area weightage method. I hope you remember it. Yes or no? Yes or no? I hope you all remember it. The Thyssen polygon method, in which we have to join the stations using straight lines. Okay. And then perpendicular bisectors have to be drawn, which will be extended in order to form the Thyssen polygons. Okay. So we have solved some questions. I hope you remember these questions. Okay. Very simple, basic formula based questions were there. Then I also told you about the significance of stations if they are lying outside or inside the catchment area. Okay, I have told you about this also. Then in the last class we have discussed isohydral method. Okay, isohydral method has certain advantages. Okay, it takes care of both topographical influences and also it takes care of when your rain gauge distribution is non-uniform. I hope you remember this. Okay, so this is the best one, but the problem is that it takes time. Okay, drawing such kind of isohydral map is not easy. Okay, see all the points I have already told you. So it is a time consuming method. It's difficult to draw, and if rainfall pattern changes with time, we have to draw that kind of maps again and again. Okay, we solved one question. I hope this question was very clear to you all. So basic fundamentals we have three formulas which you have to remember. Okay, in order to find the average depth of precipitation. I hope this is clear. Good evening everyone who has joined later. Good evening everyone. Okay, and at last we have discussed about DAD curve. In DAD curve, sir, basically we have concluded 2 points which we have to remember for a long time, that if area is getting increased, the depth of rainfall or the maximum depth of rainfall will decrease. Okay, this was the first you can say relation which we have to understand. But when we are you can say when we are relating depth and area, in that case duration is constant. Okay, so duration is constant when depth and area are related to each other inversely. But when we are talking of depth and duration, when we are relating depth and duration, sir, in that case area is constant. Okay, and we are interested in maximum depth because whenever we'll do the design of hydraulic structures, in that case, sir, obviously maximum depth is required. And I also told you about some simple type of DAD curves which are drawn here, the shape of it, how duration is getting changed. I have explained to you everything. Okay, here you can see that when area is same for all these curves, then duration will increase 1 hour, 6 hour, 12 hour, like that. So this is depth proportional to duration. And if you will see a particular curve, you will see that when area is increasing, depth will decrease. So till here we have covered till yesterday. Now today we are going to discuss about, wait a second. Yes, today we are going to discuss about frequency of point rainfall. Okay, it's very interesting topic. Okay, very few topics are left right now. IDF curve in this frequency, first we have to understand, then we will discuss about IDF curve, then probable maximum precipitation, and then world's greatest rainfall. These three topics are left. So today we will start a very interesting topic which is known as frequency of point rainfall. I want maximum participation from you all and I want you all to comment when I am teaching you. Okay, So I hope you all are ready with full excitement, and we are going to discuss about IDF curve. But yes, before starting IDF curve, first we have to understand, wait a second, that slide is missing from here. Yes, slide is missing. So wait a second. Before moving on to, wait a second, let me import that file. Yes, this one is the one. Yes. See how many files I have to save day in and day out for you all. So yes, firstly we are going to discuss the topic of frequency of point rainfall. Okay. Now listen to things very carefully. First, what is the meaning of frequency here? What is the meaning of frequency here? First we have to understand this. See, you all know that we have rainfall which is variable in nature. Every year you will see that sometimes less rainfall is there, sometimes more rainfall is there. So total amount of rainfall which is happening annually changes, varies. Okay, sometimes sir it is 120, sometimes it is 125, like that. You know, you can understand this. Sir, how I can ensure, or how I can find the probability or exact frequency of a certain kind of magnitude of rainfall? Okay, that study is known as frequency of point rainfall. Okay, so how this thing works, I will tell you. There is no need to worry. Okay, how this thing will work, I will tell you. So first, let me tell you how we will analyze rainfall data. Okay, so first thing, that rainfall data, when it is arranged in chronological order, it is known as time series. Very simple thing is written here. See, what is the meaning of time series? Listen very carefully. Let us say we have a data. Okay, and we will basically take annual series. Annual series means that we are interested in the rainfall annually. Okay, so let us say we have certain amount of rainfall in 2022. Let us say we have certain amount of rainfall in 2021. Let us say we have certain amount of rainfall in 2020. Like this, we have certain data. Okay, the more the data, okay, see, if we have more data, then obviously the studies will give me, or the studies will predict the better results. Okay, how this exactly is done, that I am going to tell you today. But yes, I hope time series is very clear to you. Time series simply means that year wise we have certain rainfall data. Okay, let us say in 2022 120 centimeter rainfall has been witnessed in a certain place, like this. Okay, so like this you have data. I hope this is very clear to you. Okay, and one more thing, see, what is the meaning of point rainfall here? Okay, what is the, so I hope this data thing is clear to you. This data, when it is plotted, in sequence in chronological order, it is known as time series. Everyone kindly comment, this data is known as, what? Everyone kindly comment, then I will proceed. Yes, after this, one more term which you have to understand is point rainfall. Okay, see, point rainfall is nothing but simply, let us say we have a rain gauge station, and the amount of rainfall which this rain gauge is receiving or recording is known as point rainfall. Okay, simply rainfall at any point, simply rainfall at any station in any rain gauge is known as your point rainfall. Let me write it here so that you are not forgetting this important point here. Okay, so what is time series? Time series is nothing but data, and that too chronologically, year wise, like that. Okay, so that is time series. Secondly, sir, you are saying that point rainfall is nothing but the depth of rainfall. It is nothing but it is depth of rainfall at a rain gauge station. Depth of rainfall at a rain gauge station. Yes or no? I hope this thing is very clear to you. Is known as, or is simply called as, point rainfall. Point means we are considering only one rain gauge. Okay, is called as point rainfall. Okay, sir. Now, sir, what is the frequency? Now, what is the meaning of frequency here? Sir, time series you have told me. Sir, I have understood the meaning of time series. Sir, you are saying simply we have data plotted in sequential manner, yearly manner, annual manner, like that. And depth of rainfall at any rain gauge station is known as point rainfall. Now, sir, what is frequency? See, you need to understand one thing. How frequency is evaluated? First, let me give you an example with the help of which I will explain it to you. Tell me, Let us say we have a term here. Wait a second. We have a term here known as return period. Okay, return period or recurrence interval. Many names are there. Let me write it very clearly here so that all the points are sequentially arranged. T means T means what? T means return period. T means return period or recurrence interval. See, return period means that certain event will happen after this amount of years. Let us say if certain event is having return year as 50 year, let us assume that you will qualify gate. Let us assume, let me crack a joke here. Okay, let us assume that you will crack gate once in 50 years. Okay, let us say that this uh, gate thing will happen to you once in 50 years. So the return period of this event, the return period of your gate uh, getting qualified is 50 years. Return period means that this event will happen. Obviously it's I'm just joking. Okay, it can happen every year also, but let me assume that one boy is so weak in studies that he will qualify gate once in 50 years. That if he will get if he will give or attempt gate 50 times for 50 years, then he will qualify it once only. Okay, so this is the meaning of return period. Return period means something happening, something happening periodically, something happening periodically over a certain period of time. So this is the time period of that event. This is the time period of that event. Yes or no? So after this amount of time, this event is highly likely to be repeated. Yes or no? I hope this thing is very, very clear to you. One doubt is here. I don't think that everyone will get the offer letter, Rishikesh. Okay. If seats are less, obviously some people will get rejected. That's for sure. Okay, so T means time period, return period, or recurrence interval. T means time period, return period, or recurrence interval. Okay. So T stands for recurrence interval for any event. Okay, for any event. For any event. Basically, in hydrology, sir, in which kind of event we are interested? Obviously, we are not interested in qualifying gate in hydrology. In hydrology, sir, we are interested in rainfall. Okay, any kind of rainfall event. Okay, so for any event such as this amount of rainfall will happen in how many years, or let us say some stream flow. See, we are very much interested in the stream flow. Why? Because if rainfall is more, you need to understand whenever rainfall is more, in that season only you will see that flood occurs. Flood means stream flows are, you can say, uh, will take a sharp rise. Okay, you will see that in the streams, in the rivers, you will see that flow is very, very high. So that is your flood condition. Okay, so whenever rainfall is very, very high, obviously we are interested in stream flow also. So like rainfall event we will discuss about stream flow, how much discharge is there in my river. Okay, etc. Or we can take any other events, but basically in hydrology you will see that we are more interested in rainfall and stream flow. I hope this thing is very, very clear to you. Okay, yes or no? Now let me give you an example with the help of which you will be able to understand. So now if return period is t, then what will be the frequency? Then what will be the frequency or probability? So can you tell me, have you read the formula for frequency with respect to time period? Have you heard about it? If you know it, can you tell me what is the formula for frequency? Then the probability of occurrence or frequency, then the probability of occurrence of such kind of event, then the probability of occurrence, then the probability of occurrence, or you can say probability of exceedance, exceedance is given by P equals, yes, perfect, Sushil. F is equal to 1 by T. Same formula I'm going to write here. P is equal to 1 by T here. Simple. This P is nothing but probability, or simply you can say, you can simply say frequency. Okay, both are one and the same here. Both are one and the same here. We can write it also. P is what? Probability of occurrence. P is what? Probability of occurrence or exceedance. See, what is the meaning of exceedance here? I have written exceedance. probability of occurrence, okay, or simply you can call it frequency. Now what is the meaning of this? What is the meaning of this? Let us assume that we have a certain stream. Let us assume we have a certain river or a stream, and in that we have a discharge of, let us say, 100 meter cube per second. So sir, tell me what is the frequency. See, we are designing this river, or you can say designing a bridge or dam which we are constructed on this river for, let us say, design discharge of 100 meter cubes per second. So we are interested in finding after how many years, or what is the return period, or what is the frequency of this flood discharge of this 100 meter cube per second discharge being exceeded or occurring at least once in that river, in that stream. So we are interested in that, sir. We are interested in finding the probability. Let us say this 100 meter cube per second let us say this 100 meter cube per second flood occurs once in 50 years. Basically it occurs once in 50 years, we are assuming that. So what will the probability, can you tell me what will the probability for this for this flow to happen? Okay, this kind of flow generally is experienced by the river once in 50 years. So what will the probability? What will the frequency? Sir, it's very simple. It will be none other than 1 upon 50. Yes or no? 0.02. Perfect. Because, sir, frequency is none other than 1 upon return period. Return period is 50. Okay. But, sir, can you tell me how you have exactly judged that this stream will have 100 meter cube per second of discharge every 50 years? How, sir? How this thing is determined? That I am going to tell you today in this class. Okay, so please be very attentive. It's very, very interesting topic. Okay, many things will be very, very clear to you. Okay, so sir, tell me how, and see, you need to understand if we will have a higher discharge. Can you tell me? I'm just asking you a simple question. Let me check if you are able to understand this. Let us say if this stream has to witness a discharge of, let us say, 500 meter cube per second. Okay, so can you tell me, for such kind of event, for such kind of huge event, because 500 meter cube per second discharge will only take place when rainfall is very, very severe. Yes or no? When rainfall is very severe. So can you tell me in that case, what will be the return period? Can you tell me? Will it be more than 50 years, less than 50 years, or equal to it? Can you tell me? Try to judge this. Try to judge this. I'm seeing your comments. I'm seeing your comments. Tell me, try to judge this, that what will be the return period when your design discharge has to exceed or equal, when your design discharge or flood flow has to exceed 500, or let it be equal to 500, then what will the return period? Will it be more? Yes, perfect. You are saying, Vishal and Yugal is saying that it will be more than 50 years. Perfect. Why? Sir, why it will be more than 50 years? Because you need to understand, it's a more rare event. Okay, it's a rarer event. Why it's a rare event? It does not happen oftenly. Why? Sir, because it's a rare thing. And rare thing, see, design discharges or flood flows of such high kind of magnitude does not happen oftenly. Okay, they don't occur frequently. Yes or no? So obviously the return period, let us assume the return period is 100 years. So the probability will be even less. The probability of this discharge to occur in the stream or river is even lesser. So if you will calculate the probability for the second event or second stream flow event, in that case my probability will be even lower. Yes or no? In that case my probability will be even lower, and it is 0.01. Yes or no? I hope this thing is very, very clear to you. Yes or no? Perfect. Yugal, Vishal, Sushil, everyone is guessing it correctly. So now it is even lesser. So sir, one thing we can conclude, sir, one thing is for sure, that higher the magnitude of stream flow, or higher is the magnitude of, you can say, rainfall. Okay, so higher magnitude events have a, tell me, higher magnitude events will have what sort of return period? Sir, higher kind of magnitudes will have, sir, higher return periods but lower probability, because rare events will happen less frequently with a more higher return period. Okay, yes or no? So I hope this concept is clear to. This is very, very important to understand. Okay, yes. So if return period is more, their probability of occurrence or frequency is even lower. This you need to understand. Okay, so let me write it somewhere here. I hope this concept is very, very clear to you. But sir, one thing I'm unable to understand. Okay, one thing I'm unable to understand, that if we are if we are to find the exact return period or exact probability of any sort of discharge in the river, sir, then exactly what is the method behind it, or what is the exact method with the help of which I will be able to determine probability and return period corresponding to a given stream flow, corresponding to a given discharge, or corresponding to any rainfall? Like if we have certain amount of rainfall, if we have certain magnitude of rainfall, or if we have certain magnitude of stream flow, then that event will have what kind of probability and frequency that we have to evaluate. But sir, how exactly we have to evaluate, that I will tell you. But before moving on further, first I will tell you some more things. Okay, see, one concept is also clear to us in this frequency of point rainfall thing. One more concept is very, very clear to us, sir, that if see I'm writing 2 points here, that if we are interested in getting the relationship between discharge, or let us say intensity of rainfall, with respect to return period, then obviously if higher is the magnitude of discharge and higher is the intensity of rainfall, that will have a higher return period. Yes or no, sir? That thing will have higher return period. So obviously, sir, they are inversely related. Sir, obviously they are inversely related, and you can say proportional to frequency. Yes or no? So let me give you one more example. Let us say rainfall intensity of 5 centimeter per hour happened, and because of which runoff took place, and in the stream, sir, we have a discharge of 100 meter cube per second. And let us say this event is having a return period of 50 years. Okay, so such kind of discharge and such kind of rainfall happens once in 50 years only. The probability is 1 in 50. Now the second case is, let us say rainfall intensity is 12 centimeter per hour. Because of this, discharge in the river is 500 meter cube per second after runoff. Obviously, you all know, because of rainfall, runoff will happen after some time. And for such kind of events, basically, sir, return period will be even higher. Let us assume it to be 100 years. Okay, then probability will be even lower. So higher the magnitude, okay, higher the magnitude, lower the probability. Wait a second, I have written one thing wrong here. Okay, it should be P here. Yes, you are right. Yes, P will be less. Okay, wait. Yes, you are right. T will be more and P will be less. Yes, perfect. So higher the intensity of rainfall, higher the discharge. Sir, in that case, return period will be more. Okay, so they are proportional. Return period will be more, but probability will be less. Okay, see, when you will apply the logic, you will obviously get this concept. See, rarer event, higher magnitude event will take place in, you can say, more number of years. Okay, let us assume, let me give you some examples. Okay, you must be very much familiar with the Kedarnath flood or Uttarakhand flood, which happened in 2013. I hope you remember that flood. Okay, everywhere it was in news. So see, such kind of discharge, such kind of rainfall has happened in, you can say, in 2013 last time, and such kind of rainfall hasn't happened in the last 50 years. So you need to understand, such kind of flows and such kind of rainfalls generally doesn't happen oftenly. Okay, so you will see that such events are rare. So obviously those return periods are very high. Okay, I hope this thing is very, very clear to you. Or in your area in which you are living, you must have also not witnessed flood often. Okay, if you'll ask your fathers, forefathers, grandfathers, they will tell you that yes, in 1962 in our area flood was there. Okay, so obviously from 1962 we are in 2022, 50 years gap is there almost, and still there is no possibility of occurring any kind of flood. So obviously it's a kind of probabilistic approach. Okay, so I hope this concept is clear to you. Let me write one point here, then we'll move ahead. That the higher the magnitude of stream flow, let me write intensity of rainfall first. The higher the magnitude of intensity of rainfall, the higher the magnitude of intensity of rainfall, comma stream flow, the higher will be the return period. The higher will be the return period, because it will be rare. Such kind of events are rare. Okay, the higher will be the return period. and lower will be the probability or frequency. Lower will be its probability or frequency. Probability and frequency are one and the same here. So I hope now frequency term is very clear to you, and vice versa is also applicable. Okay, vice versa statement is also clear here. Okay, I hope this is clear to you. Is this thing clear? Perfect. Yes, drought event also. Yes, drought also. Perfect. See, any kind of event, be it a let us say you can say event of scarcity, or be it a event of excess, but basically we are going to discuss about exceedance thing. Okay, we are more interested in higher magnitudes right now. Okay, we are not interested in droughts right now, that's why. Sir, we can also get the probability of maximum rainfall by normal precipitation. No, wait a second, Sushil. First try to understand the concept which I am going to tell you. You will easily understand all the things. Okay, please be patient and try to listen very carefully. Now, one thing is for sure, sir, any kind of event which you are talking of, it is having a probability of P. P means, sir, P simply stands here for probability of occurrence of any event. Probability of occurrence of such kind of discharge, probability of occurrence of any kind of discharge, 100 meter cube per second, 500 meter cube per second, like that. So P is what? P is probability of occurrence. P is what? P is probability of occurrence of any event. Okay, probability of occurrence simply. Now, what will be Q? Q, see, if rainfall is happening with a probability of 1 by 50, then can you tell me what is the probability of not happening of such kind of rainfall? Can you tell me the meaning? See, Q means probability of non-occurrence, that such kind of event will not take place. Okay, probability of non-occurrence. So can you tell me, if probability of occurrence is 1 by 50, then what will the probability of non-occurrence? Can you tell me? Yes, you are correct. You are guessing it absolutely correctly, because the sum of both the probabilities P plus Q is 1. Yes, we will subtract it from 1. Perfect. You know it is thing. Okay, so it will be 49 by 50. Perfect. You are guessing it absolutely correct. See, if probability of your gate qualifying is, let us say, 1/6, then obviously for not qualifying it is 5 by 6 when you will subtract it. So we all have understood very clearly, sir, one thing here, that P plus Q is 1. This is general logic. So let me write it here only, that P plus Q is 1. Perfect. Great. I hope this thing is very clear to you. So this you have to remember. Now, we need to understand 3 formulas from here, which we will understand with the help of a example also. Very important. Many times question have been framed in your past examination. Okay, so listen very carefully. So one formula which you have to understand is, let me write it here on this page or on the next slide. Let me use the next slide. So I am going to tell you about probability of, I have to tell you 3 points basically. On this slide I will write only 3 points. These 3 points are very important, the most important slide of today's class discussion. Okay, this is very important, so listen very carefully. Okay, so first thing which I am going to tell you is the probability of any event. Obviously, which kind of event we are talking of now, I think you are familiar with it. Okay, so probability of any event happening, r times, probability of any event happening r times in n successive years, r times in n successive years, in n number of, in n successive years. So can you tell me what will the probability? Do you know this thing? In n successive years is given by, let me write it here. So probability of x equals to r. See, x can have a value which will vary from 0 to n. Obviously, you know, we have n years. That event can happen in 0 years also, in 1 year also, in 2 year also. Out of n years, it can happen in 0, 1, 2, 3, 4, up to n years it can take place. So x is a random variable which will take place which will take place, and obviously its value will be from 0 to n. So the probability is given by NCR P power R Q power n minus R. Sir, how come this formula? Can you tell me the explanation why this formula we are using? Okay, we will understand with the help of an example. Okay, so that everything is very clear to you. And two more things after this we have to understand. Okay, so wait, you will understand very clearly. Okay, so now I'm going to take an example. Okay, now I'm going to take an example with the help of which you will be able to understand it very clearly. Okay, so I will take an example in the next slide. So let us assume, wait a second. Okay, so we'll take an example, and with the help of this we will understand this entire logic in this question. Okay, so sir, you are saying let us assume that design flood is greater than equal to 500 meter cube per second, which means what? That I have designed a hydraulic structure. Let us take an hydraulic structure also. Let us assume we have a hydraulic structure which we have to construct on this river. Okay, let us say we are constructing a bridge. Assume we are constructing a bridge. I hope you must have seen road bridges across any kind of river. You must have seen it. You must have witnessed it. Okay, so we are going to construct that bridge, and its design life, let us say its design life n is 50 years. We are assuming it. Okay, we are simply assuming some data in this question, and then I will tell you how this probability things out, which is occurring r times, event occurring r times out of n times, this we have to solve. Okay, yes, you have seen the bridge definitely. So let us assume its design life is 50 years. Okay, now this design flood, let us say the written period of such kind of flood happening in the stream. Okay, written period of such kind of flow, 500 meter cube per second. It's a high flow. Obviously it's a high flow. Such kind of flood occurring in the river, let us say it is equal to your somewhere around, let us assume 100 years. So approximately once in 100 years you will see 500 meter cube discharge is there, or greater than that discharge is there. Exceeded or equal. Remember two words. We are saying equal and greater than. We are saying greater than equal to, or we are simply saying equal or exceeded. See, I have written one term here. Exceedance. What is the meaning of exceedance? Exceedance means the probability, we are interested in the probability of that magnitude getting equaled or exceeded. Sir, the discharge in the river is getting equal to 500 or it is exceeding it. Okay, and this happens once in 100 years. Sir, such thing happens once in 100 years. So this kind of question will be given in examinations. Okay, now what? Sir? See, the value of n, design life, is given to you 50 years. Okay, perfect, sir, no problem. Can you tell me what is the probability here for this event? See, this is the event. I hope this you have understood already. This is the event. This is the event which happens likely once in 100 years. Okay, so written period is already given to you. So tell me, I will write the solution here. Can you tell me what is the probability of occurrence of such kind of flood? Sir, obviously the probability of occurrence of such kind of flood is nothing but 1 upon t. Yes or no? Can you tell me? See, please stay focused. This is very important numerical which will be asked in your examination. Yes, 1 by 100 Vishal, perfect. So probability of such kind of design flood occurring in this river is none other than 1 by t, 1 by 100. Okay, perfect. Now, what will the probability of non-occurrence? Tell me that thing also. Tell me what will the probability of non-occurrence? Yes, perfect. 0.01 is the answer. And probability of non-occurrence will be, yes, perfect. It will be 1 minus p. It will be 1 minus p. Yes, you are absolutely correct here. It will be 1 minus p, simply 99 by 100. Now, sir, what is the meaning of this line? See, Here we have 50 successive years. In our example, sir, we have considered 50 years consecutively. Now, how many cases can be framed? Sir, here you are saying that R will vary from 0 to 50. R will, how? How, sir, this thing will happen? Can you explain it to you, explain it to me in the example itself? So wait a second, let me draw a line here. Now listen very carefully. Okay, sir. So you are saying, see, the value of R can change. Okay, obviously the value of R can change. Let us say the value of R is 0 right now. Okay. Let us say the value of R is 1 right now. Sir, what is the meaning of R equal to 0, R equal to 1? See, we have total 50 years. How many years we have? Sir, we have total 50 years. I hope this is very, very clear to you. So now in 50 years, sir, now in 50 years, what will happen? Sir, out of 50 years, this flood can occur 0 times. And wait a second, I will write P here and I will write Q in the second column. Now, sir, what is the meaning of this? See, if R is 0, it means out of 50 years, in not even a single year, this design flood, or you can say this magnitude of flood has happened. Out of 50 years, sir, we can have many cases. Out of 50 years, this flood has never happened. Okay, that's why I'm writing 0 here. This flood has never occurred. That's why occurrence probability is 0. And let us say out of all the 50 years, we are safe. This flood has never happened. What can be the next case? Next case can be that this flood has happened only once in 50 years. Out of 50 years, only in a single year, this flood has come. Okay. Only in 1 year, this kind of flood we have witnessed. And in remaining 49 years, sir, we have not seen such kind of flood. This can be the case. What else? Sir, what else? Can you tell me? Sir, also we can have R equal to 2, which means that such kind of flood has occurred only in 2 years. Out of 50 years, in only 2 years, sir, such kind of flood has took place. Okay. Yes or no? Have took place. Okay, now. And obviously, if it has taken place 2 times, then obviously for 48 years, it must not have occurred. So out of 50 years, in any 2 years, this flood has occurred. Yes or no? Have you understood this concept? Likewise, how many cases will be there? Sir, obviously, if R is equal to 3, it means that such kind of flood has taken place only 3 times out of 50 times, and remaining 47 years, and in remaining 47 years or remaining 47 times, we have not witnessed such kind of flood. So this can also happen. Likewise, it can happen 4 times, and in 46 years it cannot happen. 545, 446, like that, so on and so forth. At last, which case we will have? At last, we will have a case in which in all the years, okay, in each and every single year, this flood has occurred, and not even a single year was there when this flood has not taken place. Okay, in all the 50 years. See, this is a very rare kind of probability. Okay, such kind of flood which is so rare, obviously it will not take place in all the years. Okay, because its probability is very, very less. So now, sir, tell me how to evaluate the probability of any single case. If I want to evaluate the probability that this kind of flood is occurring 0 times out of 50 times, what is the probability? What is the probability that such kind of flood is occurring once only in 50 years? Sir, what is the probability that this flood is occurring exactly 2 times out of 50 times? Sir, what is the probability that this flood is occurring 3 times out of 50 times? So we have different cases, and we can find any probability here. Okay. Yes. Perfect. So can you tell me what will the probability for the first one? Can you tell me what will the probability for the first part here? So the probability of such kind of thing is here. See, I have told you that when x is equal to r, or simply r is equal to 0, here we'll put 0. Okay. And here I will put 50 minus 0, n minus. So let me write the formula here. The formula will be, kindly guess, tell me when this flood will never occur. Okay, out of 50 years. So the probability will be n c r p power r q power n minus r. This is n is 50. So it simply means that probability of occurrence is 0 and non-occurrence is 50. That's why we have raised q to the power 50 and p to the power 0. Is this thing clear? See, this is very, very important. Listen very carefully. Okay, if in exams they are asking you like what is the probability that such kind of flood takes place only once out of 50 years, so what will the probability? Can you comment it? Can you comment it? What will the probability? So probability will be 50C1. Now R is 1, sir. Yes or no? Yes or no? The value of R is 1. Tell me, is this thing clear? The value of R is 1. So obviously 50C1 P power 1. Why P power 1? Because it is occurring once and it is not occurring 49 times. 50 minus 1. 49 is 50 minus 1. Yes or no? Is this thing clear? Kindly comment yes. Now tell me, what is the probability that if this flood is occurring only 2 times or exactly 2 times out of 50 times? What is the probability? Can you tell me? Now kindly comment. Now kindly comment what will the probability here? Can you guess it? Can you guess it? What will the probability? What will the probability if your flood has to occur exactly 2 times out of 50 times? Then the answer will be yes, you are guessing it correctly. 50C2 P power 2 Q power 48. Perfect answer. Great. So likewise you can find, likewise sir, you can find the probability of any event. And which kind of event we have taken in our example, sir? We have taken event to be design flood which is exceeding 500 meter cube per second. This is our event. Okay, so probability of probability of any event happening r times out of n times or out of n successive years, yeah, in successive years, is none other than NCR P power R Q power n minus R. Okay, I hope this thing is very, very clear to you. This is very, very important. You have to remember it. Okay, similarly for this last event, you can find the probability as 50C50 because R is 50 years. See, this is very rare. See, such kind of flood which is already very, very rare, that will not happen every year. Yes or no? That will not happen every year. In every year, sir, you are saying that this flood is occurring. So obviously this probability will be very, very least, or you can say almost equal to 0. You can evaluate it also. P power 50, Q power n minus 50, n minus R. 50 minus 50 is 0. Okay. So see one more thing. When you will sum up all these probabilities, when you will sum it up, when you will sum up all the probabilities, if you will take the probabilities of all the cases and sum it up, can you tell me what will the total probability? Try to guess it. What will be the total probability? Can you guess it? If I am going to do the sum of all these probabilities, what will be the total sum? Can you guess it? Yes, sir, it is perfect. Sir, total probability will be, total probability when I will sum up all these values will be equal to 1. Yes, you are guessing it correctly. 1 will be the answer. Perfect. Perfect. The total probabilities of all these cases will be equal to 1. Obviously, summation is 1 every time. Okay. So, what sort of questions will be there in my examination? Okay, in what sort of questions we will have in examination? See, basically 3 kind of questions they will ask you. Basically 3 kind of questions they will ask you. They will ask you the first case, the first case which they will ask you, like find the probability, find the probability that this flood event, find the probability that, listen very carefully. See, such kind of questions have been directly framed in examinations. That's why I'm giving so much of time. So listen very carefully and try to find it. Also take out your calculators and try to solve, okay, in the class itself. So find the probability that flood event occurs, okay, flood event occurs or happens 2 times in 50 successive years. Okay, because our design life is 50 year. So can you just tell me just this probability? Second type of question which is generally framed, they will ask you about reliability. Okay, what is reliability? And third kind of question which they will ask you is risk. What is the risk involved here? What is the risk involved here? So this you can easily find. I hope by this time second part is first part is very, very clear to you. You all know that we will evaluate this with help of simple formula. We know that we are interested in finding the probability when my random variable takes value equal to 2 out of 50. Okay, so the formula is nothing, NCR, let me write it directly. We will write 50C2 P power 2 Q power 48, because out of 50, sir, this event is happening 2 times and 48 times it is not happening. Yes or no? Sir, for 48 times it is not happening. Okay. So can you find the probability? 50C2, P is how much? Sir, P is given to me as 1 by 100. Okay, you can see it from here. P is given as 1 by 100, 1 by 100 power 2, and Q power 48. Try to evaluate it and tell me the answer. 50C2 you can simply evaluate in the calculator. See, try to evaluate it also. Okay, don't just give the expression, try to solve it also. I hope you all know how to evaluate NCR. I hope you all know how NCR term is evaluated. Okay, if you don't know it, let me write it here. If you don't know it, NCR is evaluated simply doing n factorial in the numerator divided by r factorial multiply by n minus r factorial. So let us say if someone is telling you to write 10C2, this is 10 factorial upon 2 factorial into 8 factorial. 10 minus 2 is 8 factorial. Okay, see, in 10 factorial we have multiplied from 1 to 10. Here we have multiplied from 1 to 8, so they will get cancelled. Only 9 and 10 will be remaining. Only 9 and 10 will be remaining, and from 1 to 8 is 8 factorial, which will get cancelled. And in the bottom we will have 2 factorial. Okay, so one trick is there. One trick is there when you want to solve 50C3 directly. We have to write 50, 49, 48. We have to write 3 terms. We have to write 3 terms, 50, 49, 48. Decrease the value of n 1 by 1 for 3 times. Okay, divide by 3 factorial. Divide by 3 factorial. If we are to write 10C2, so write 10, decrease its value 1 by 1 and write only 2 terms. Write only 2 terms. And in the denominator, write 2 factorial. Okay. So I hope this thing is very, very clear to you. In such fashion, you can evaluate combinations. Okay. But if you have calculators, directly evaluate the value and tell me how much we are getting here. Tell me how much we are getting here. What is the value which we are getting here? You are saying, Kiran is saying 0.075. Okay, perfect. Perfect, Kiran. So you are saying that solution to this expression is 0.075. Everyone else is getting the same answer? Everyone else is also getting the same answer? Yes or no? Perfect. 0.75 is the correct answer. Now sir, tell me what is reliability and what is risk. Okay, so for reliability and risk, we have to see, I am just assuming now, or I am simply expecting that you are familiar with this concept. Whenever such kind of question they can also ask you like find the probability that flood event occurs 3 times. Okay, out of 50 times, 4 times. So this probability you can simply find. Okay, I have simply explained it to you with the help of a beautiful example. I hope this thing is very, very clear to you. Now sir, you have to tell about you are about to tell now reliability and risk. Now what is the meaning of reliability? See, reliability means what? Reliability means, sir, this flood is never occurring. See, you can rely on this flood. You can rely on this flood when it is not occurring, sir, because if we want to ensure that my bridge is perfectly safe, if I want to ensure that my bridge is perfectly safe, or we are, you can say, fully reliable, then obviously we will expect that this flood is not occurring even a single year. This flood is not occurring once in 50 years. Never this will happen. Never this will happen. So that is known as reliability. So meaning of reliability is, let me write it here. Okay, I have already left some space here. Let me write. See, we are interested in knowing. Now we are interested in knowing reliability and risk. So tell me, sir, what is the meaning of reliability and what is the meaning of risk? Sir, you are saying reliability means that such kind of flood event never happens in 50 years. Never it will take place. So can you find the probability when this event will not take place even a single time? Can you find the probability? Can you find the probability? Tell me yes or no. Kindly comment in the comment box. What is the meaning of reliability? So reliability means that probability that the event and what sort of event we are talking of? Rainfall or stream flow. Okay, any kind of rainfall event or any kind of flood flow event. Okay, so what I'm saying here is that probability that the event will never occur Probability of the event that it will never happen. Probability of the event that it will never happen in n successive years, that it will never happen in n successive years, is known as reliability. Is known as reliability. Sir, how I will evaluate it? It's very simple. It's very simple. See, if you want that R is 0, okay, you want that out of 50 times it is never occurring. That means out of all the 50 times you are safe every time. Every year you will not see such kind of discharge happening. Or yes or no? Yes, perfect, Kiran. We are interested in finding R equal to 0. So what is the probability here? So sir, obviously the probability will be equal to NC0. Obviously we have put R equal to 0, P power 0, Q power n minus 0, that is n. Okay. So finally, see, NC0 is 1. If you will solve, obviously NC0 is 1, n factorial upon 0 factorial upon n minus 0 factorial is 1. Yes or no? Yes, sir. Anything raised to power 0 is 1. So we will be left only with Q power n. Q power n. Yes or no? Or we can also write, in place of Q, we can also write 1 minus P. In place of Q, we can write 1 minus P. And in place of P, I can write 1 upon T. Today I have told you. Okay, so remember this formula. This is very, very important. This is formula for your reliability. Okay, so out of all these cases, sir, you are simply saying, if we are finding the probability of this event, this probability is known as, tell me, this probability is known as what? Sir, when this flood event will never take place, okay, when this flood event will never ever take place out of 50 times, this probability is known as, tell me, this probability is known as, can you tell me? This probability is known as, when this flood event will never occur out of 50 times, this probability is known as, perfect, you are saying, guessing it correctly, this probability is known as reliability. This probability is known as reliability. Yes, perfect. Perfect, Sushil. Perfect, Kiran, everyone. Now we are interested in risk. Now, what is the meaning of risk? Can you guess the meaning of risk here? See, risk means what? Even if this flood is occurring at least once, even if it is occurring once out of 50 years, obviously my structure will be at risk. Yes or no? My structure will be at risk even if this flood occurs at least once. Okay. Even if it will occur once, then I will say that my structure is not safe, it is at risk. Okay, it can occur, see, listen very carefully, at least once means, see, this flood event, if it will occur once, or if it will occur twice, or if it will occur thrice, or no matter, sir, how many times it takes place, but if it has happened only for a single time, then I will say that my structure is at risk. Yes or no? So risk means what? So risk means that even if this flood event is taking place at least once, you have to remember, this is the keyword. If this flood event is happening at least once, then I will say it is risk. And how I will evaluate its probability? Can you guess it? So let me write here the meaning of risk. Risk is what? So risk is what? Probability that the event will occur at least once. This is the keyword. At least once in n successive years. So if it will occur at least once, then it means risk. And how I will evaluate its probability? See, probability, if I want to evaluate, see, what I have to do, I have to find this probability, like this. We have to find probabilities of all these cases and sum it up. But it will be a very tedious process. Yes or no? It will be a very tedious process. Yes or no? Risk. Yes, perfect. So what I will do here is, I will sum up all these values. See, we have to find the sum of all these values. Okay. See, we have to find the sum of all these values. This is risk. Yes or no? So what I will do, I know the probability of all the sum is 1. This we have already found out. So I will simply subtract this probability from 1. Okay, I will subtract reliability from 1 and I will get the sum of remaining values. Yes or no? So risk is nothing but Risk is nothing but reliability minus 1 minus reliability. Yes or no? Yes, perfect. You are guessing it correctly. So risk is nothing but 1 minus reliability. Reliability is what? Q power n. Reliability is what? Q power n. In place of Q, you can write 1 minus P. And in place of P, you can write 1 upon T. All are one the same, sir. But one thing which we have understood here clearly, sir, one thing is for sure, that risk plus reliability is equal to 1. Risk plus reliability is equal to 1. Okay. Risk plus reliability is equal to 1. This we have understood very, very clearly. This is important. Okay. So can you tell me risk or reliability, which is more favorable? Can you tell me which is more favorable here? Can you guess which is more favorable, sir? Obviously, reliability is more favorable, because in that case, sir, we can say that probably we are more reliable, that this kind of flood event will never take place in design life. In its entire design life, if this thing will happen, flood will never occur. Obviously, we are reliable. That is more favorable. Yes or no? Yes or no? Perfect. Now tell me, I have given you one question. Tell me, I have given you one question. So can you solve the value for reliability here? See, remember the keyword. Remember the keyword. The keyword for reliability is that it will never happen, never occur. Okay, the keyword for reliability is will never occur. Such kind of flood event will not even take place even a single time out of 50 years. And what is the meaning of risk? Risk keyword is at least once. Remember this keyword, at least once. At least once this flood will happen. At least once this flood event can take place out of 50 years. At least once or twice or thrice. Okay, if even once it has occurred, then I will say that my structure is at risk. Okay, perfect. So tell me how much reliability we are getting here. Keyword I hope is very, very clear to you. Let me write the keyword here in bracket. Will never occur or will never happen. Reliability means it will never happen. So reliability is given by simply Q power n. What is Q? Value of Q? Q is 99 by 100. And you all know that n is 50. You all know that n is 50. So 99 by 100 power 50 is none other than 0.605. Okay. Yes, perfect. You are saying 0.605. Perfect. So if we want to write, Kiran, if we want to write this in percentage, what will the value? See, this is in fraction. Percentage for getting, in order to obtain percentage, we have to multiply this by 100. We have to multiply this by 100. So it will be 60.5%. See, imagine out of 100%, okay, imagine out of 100%, 60.5% chance is there that this flood will not even take place for a single time. This flood will not take place even a single time out of 50 years. This thing has a chance of 60%. That out of total 100%, 60% chance is that this flood will never ever happen in 50 years. Okay. Yes or no? Perfect. Now tell me what is risk here. Risk means, sir, risk means at least once. I will write the keyword here. Risk means at least once, and I know that risk is none other than 1 minus reliability. So what I will do, 1 minus Q power n. See, remember this formula. This is very, very important. I'm repeating again. Finding reliability and risk is very, very important for you all. Many a times it has been asked. So 1 minus Q power n. So we know what Q power n is. Q power n we have just now evaluated. So it will be 0.395. Perfect. You are guessing it correctly. And if I want to convert this fraction into percentage, I will multiply it by 100. So it is 39.5%. So can you just guess the anomaly here, that out of all the 51 cases, this single case is having 60.5% probability, and all of them, when all of them will be combined, at least one case, when all of them will be combined, they will have total probability of 39.5% only. So this total is 39.5%, and this single thing is having probability of 60.5%. What does it tell? What does it tell? Can you tell me? This simply implies that this simply implies that it is highly likely that the number of times flood will occur will be very, very low. the number of times for which the flood has to occur will be very, very low, that thing is more likely. Yes or no? If you will find this probability, for the case 1, this will be highest. Second highest probability will be this probability. Third highest probability will be this one. As you will increase, the number of times the flood event has to occur, as you will increase the number of times the flood event has to occur, its probability will start decreasing and it will become very, very low. If you will evaluate this probability, you can find it. When you will solve this probability, it will be almost equal to 0.00 like this. Try to solve. You can simply find it. Yes or no? Yes. So what we are saying here is, sir, as the number of times the flood event has to occur is increasing, the probability for that case will be very, very low. Okay. See, let me write some probabilities here. See, the first part when you will solve, we are getting it as 0.605, approximately 60%. For the second part, we are getting it as, can you tell me what is the probability for flood event to happen once? Find it quickly. Wait a second, I will also find it. For flood event to happen only once, what probability we will have? Solve it, everyone. Solve it. I am also solving it quickly. So we have in calculator NCR, yes. So 50 C1 is 50 multiplied by 0.01 multiplied by 0.99 power 49. This will be equal to how much? 0.305. Yes, this will be 0.305. This one will be equal to how much? 50 C2 multiplied by 0.01 power 2.99 power. This will be equal to 0.075. 0.075. When you will round off, it will be equal to the C. This probability is getting decreased. Okay. When you will find the next one, it will be 0.00 like this. Okay. So when you will calculate probabilities for the next cases, it will be even lower, and when you sum it up, it will be equal to 1. So you can see the highest probability, the probability is highest for the first case. Okay. When you have the least number, when you can say when we have the occurrence of flood for the least number of times. In this first case, our flood is not occurring even a single time. That case is having the highest probability. Okay. So like this, you can evaluate. Okay. Like this, you can evaluate, and you will obviously notice that as we are increasing and as we are increasing the number of times flood occurrence, you will see that probability will decrease. Okay. So simply, sir, we can say that more the number of times flood has to occur, the probability of that case will be even lower. Okay. And you can say very, very low. When you calculate the probability for the next cases, further cases, you will see that probability has decreased further. So I hope such type of questions you can easily evaluate in examination. Okay. I hope you are fully clear with this thing. Yes or no? Tell me. I hope you are fully clear with this concept. See, this slide is very, very important. You can take a screenshot if you want. It is very important. You can easily find questions from this topic in any kind of state examination, or be it GATE or be it engineering service. So let me take a test. That if you have clearly understood this thing. Okay. Let me give you an example, and we'll also solve it. Okay. We'll solve it. Okay. So we have an example here. I am going to test you that if you have understood this concept clearly or not. So we have a question here. You have to answer all these parts ABC. If you will clearly answer these parts ABC, then I will be very, very confident that you will be able to solve it in examination also. Okay. Sushil, Kiran, Yugal, everyone start solving such kind of question. I will also help you. Till then, let me drink some water. Tell me what answer we will have. So basically this question is saying analysis of data on maximum one-day rainfall at a place indicated that a depth of 200 mm had a written period of 50 years. Okay. We have a rainfall event here. One-day rainfall is the event. maximum one day rainfall is the exact event, and it indicated 200 mm depth. This is the event exactly, and return period is 50 years. Determine the probability of a one day rainfall depth equal to or greater than 200 mm at that place occurring once in 20 successive years, two times in 15 successive years, and at least once in 20 successive years. So this you have to find. Very good, Sushil. Very good. Perfect. Try to solve it. Try to guess the answer. Perfect. You are giving right answers. All of you are giving right answers. Yes, perfect. 0.272, 0.323, and the third one is 0.333. Great. Great. Perfect. So simply what we have to find here, that see in this question you can see that event is one day rainfall. Okay, event is one day rainfall of magnitude. Here we have rainfall event. Okay, depth has to be greater than, in one day rainfall the depth has to be greater than equal to 200 mm. This is the event. Okay, in our last question, sir, the event was, in our last question the event was that flood event was there, in which we have more discharge than 500 or equal to 500. Here we have depth of rainfall more than 200 or equal to it. Okay, so obviously the probability of such kind of event happening is 1 by t. Return period is 50. So probability will be 0.02, and such kind of event not occurring is equal to 1 minus p, which is 0.98. So this is simple thing which is given in question. Now how I will solve the first part? Sir, for first part, r is 1, it has to happen once. R is 1 and n is 20. Sir, we know the formula for x equal to 1. What is the formula, sir? NCR p power r is 1, and q power n minus r, 20 minus 1 is 19. Okay, so you will solve it and you will get it as 0.272. Absolutely correct, Sushil. You are getting it absolutely correct. Okay, second case, sir, for second case, sir, r is 2. Okay, 2 times in 15 years. So for second case, sir, r is 2 and n is 15. Sir, we know the formula that when x value will be equal to 2, or simply when your flood has to occur 2 times out of 15 times, obviously the probability will be NCR, n is 15, C, r is 2, p power, sorry, r is 2, let me write 2 here. Value of p is 0.02, p power r is 2. Okay, q power n minus r, 15 minus 2, which is 13. 15 minus 2 is 13. Okay, so it will be equal to 0.323. Perfect. 0.323 you are saying. And for the last case, for the last option C, we have to find at least once in 20 years. So this is the meaning. Simply it means that we have to find risk. Okay, at least once means what? At least once means risk we have to find. Okay, sir, we are interested in finding the flood occurring at least once, twice, thrice, like that. Okay, so risk is equal to how much? Risk is equal to how much? 1 minus q power n. 1 minus q power n. So what is Q here, Q is 0.98, we have already discussed, and the value of n in the last case, the value of n in the last case is 20. So when you will solve it, you will get it as 0.332, I guess. Okay, you are saying it 0.3323, yes, 0.332 simply. Perfect, Sushil. So I hope with the help of this example, you are more confident now, and you will be able to solve any kind of question which will be related to this topic in examination easily. Okay. So I hope this thing is very, very clear to you. Perfect. Kiran, Sushil, everyone. I hope such kind of numericals you can easily solve in examination. Perfect. I hope this thing is very, very clear now. Shall we proceed? Shall we proceed? Shall I proceed? Tell me. First tell me, then I will move ahead. So this frequency of point rainfall thing should be very, very clear to you. Now, the question is, sir, how you are exactly able to determine that return period of such kind of rainfall event is 50 years? Sir, how we can conclude that return period is exactly 50 years? Okay, see, the question is, listen very carefully. Sir, now the question is that this flood event is having a return period of 100 years. Sir, how you have said that thing? How this discharge, how this magnitude of discharge will have such kind of return period? Sir, how I will evaluate return period or probability of any kind of event? This I want to know. Okay. So this is the question now. This is the question. So the answer to this question is, see, simply you have understood one thing. Wait a second. See, you have understood one thing, dear. Listen very carefully. See, you have understood one thing, that whenever, see, we are interested in finding the probability of occurrence or probability of exceedance. Exceedance means greater than equal to. Sir, we are interested in finding the probability of any event. Okay, we are interested in finding the probability of any event of rainfall depth more than this value, or let us say discharge. Okay, both these events probability we are interested in finding. And sir, you have already told me that higher the intensity of rainfall, higher the depth of rainfall, or higher the discharge, higher will be its return period, but lower will be its probability. This we have already discussed. Okay, but sir, the question is that exactly this kind of discharge and this kind of depth will have what sort of return period? We have to find that. Okay, so for finding, let me tell you, let me write this point here. For finding, okay, sir, for finding return period, for finding return period or probability, for finding return period and probability for a given depth of rainfall and discharge, we have two methods basically, but I will only explain to you the one. I will only explain only one method. Okay, so for finding return period, so for finding return period and probability, for finding return period and probability of any event, for finding return period or probability of any event or its exceedance or its value getting exceeded or its exceedance. See, exceedance means what? Exceedance means the value of this depth will be equal to or exceeded. Okay, will be equaled or exceeded. Okay, so we have two methods. Sir, we have two methods. Okay, sir, tell me what are those two methods? Sir, tell me what are those two methods? So the very first method is, empirical methods. Okay, and the second methods which we have is analytical methods. Obviously, we are not going to discuss analytical methods right now. Okay, we will only focus on empirical methods, which are little important because empirical methods have been asked in your engineering services examination. Okay, in your prelims examination, preliminary one, and your mains examination, this empirical methods have been asked when you are required to find return period and probability of any event corresponding to a given magnitude. Okay, so empirical methods, see, basically we have many empirical methods, but we will only focus on three methods now. Okay, we will only focus on three methods. The first one is Weibull method or Weibull formula. Okay, empirical formulas we have. We will directly use those formulas in order to find the written period or probability. Okay, simple formulas. I will explain it to you with the help of an example. No need to worry. So we have Weibull formula, we have California formula, we have Weibull formula, we have California formula, and the last one which we have is Hazen formula. Okay, so we have three formulas. So we have three formulas: Weibull, California, and Hazen. Okay, so listen very carefully. Sir, how exactly we are going to use these formulas? See, first let us check the three formulas. Okay, these three formulas are written here. Weibull formula is m upon n plus 1, California formula is m upon n, and Hazen formula is m minus 0.5 upon n. You must be wondering, see, these are the formulas for probability. These are the formulas for probability which these scientists have given. See, these are the name of scientists: Weibull, California, Hazen. Many others are also there, but these three are important. No question can be framed out of this. But yes, the first one is most important. Let me tell you here. The first one is the most important one. Okay, first one is the most important, which can be asked in your examination. Okay. Now, sir, tell me the procedure as to how. With the help of this formula we are able to find the time period and probability corresponding to a given magnitude of rainfall depth or stream flow or any kind of discharge. Okay. So listen very carefully. So what I have to do, first I have to arrange all the data. See, we will be analyzing the data. Okay, we will be analyzing the rainfall data, or let us say stream flow data. Okay, with the help of that we will simply find the probability or time period. So what I have to do, see, I hope by this time rainfall data or stream flow data, when it is arranged in chronological order, is known as time series. So what I will do in the very first step, sir, I will obtain annual time series, or simply I will obtain data. See, if we are studying a river, what I will do, let us say this is a river. For every year, let us say 2022, what will be the highest discharge that I will plot here? So let us assume that in this river, in year 2022, the highest discharge is, let us say, 150 meter cube per second. In the year 2021, the highest discharge in this river was, let us say, 135 meter cube per second. Like this, I will collect the data. So this data is known as annual time series. Why annual, sir? Sir, why the name annual is here? Because we are collecting yearly data. Okay, for every year we are interested in recording the highest value. Okay. Similarly, you can note down the highest values of rainfall at a given station. Okay, let us say this is a rain gauge, and in this rain gauge, what is the highest rainfall recorded in any kind of year? Okay, so like this we can obtain rainfall data also, or stream flow data also. But the thing is that we should have data. With the help of that data we will be able to arrange it. Okay, so sir, how we will do it exactly? Can you tell me this thing? Yes, I can tell you, but let me show you with the help of an example. If example is clear to you, then I will write down the step. With the help of that, everything will be clear to you. But first remember this formula. Okay, so what I have to do, see, I will explain it to you with the help of an example. I have taken this time series, annual time series. You can see how many years we have. Can you tell me in this illustrative example how many number of years we have here? Can you tell me? Sir, we can see that the number of years which we have here is 5. Okay, we have n value as 5. So obviously data is very small as compared. See, generally when we have to predict the time period or probability, sir, obviously we will take huge data for, let us say, for 50 years, 100 years, like that. But obviously I just want to demonstrate how this thing works. I have taken a very small data, because see, if I will write 50 data here, obviously it will be a huge mess, and obviously those calculations will take a lot of time. So obviously I have taken here a small data just for the sake of explaining it to you. Okay, so you need to understand, if data is big, okay, if we have n value as 50, if we have 50 points, if we have 100 points, then obviously it will give better prediction. Yes or no? Yes or no? It will give better prediction. So, but only for the sake of explaining, I have taken a small data here. Okay, so can you tell me, is this rainfall data or stream flow data? Sir, obviously this is rainfall data. In 2001, the highest amount of rainfall is 24 centimeter in a single day. In 2002, the highest amount of rainfall is 15 centimeter in any kind of day. Like this, we have arranged the maximum rainfall values. Okay, now Sir, what are the steps? What are the steps? Step number 1 is, after obtaining the data, see, I have given you the annual time series in the question, yes or no? I have given to it. Now, step 1 is you have to arrange that data in descending order. This is the first step. First step is arrange the data, arrange the past record which you have. See, the past record should be big. Okay, it should have 50 points, 100 points, like that. Then you will get good results. So arrange the past record in descending order. Okay, arranged the past record in descending order. This is the first point. Okay, sir, so I am going to do this first point. So what I have to do now, sir, this is the data which is given to us. Now what I will do, I will write a value of m here. M means rank, m means order, rank or order we can write. Okay, what is the meaning of m here? Let me write it here also. What is the meaning of m here? M means, here we have two things. M means rank. See, the highest value will have the best rank or the first order, and n is number of years or how much data you have. Okay, n is total record length, of record. Okay, so the very first column, sir, which you are saying we have drawn is m. So if you will arrange it, see, first what I have to do, I have to arrange them. So first I will arrange it. Okay, so I will not write here, I will arrange them. See, if you will arrange these datas, obviously, which one is the highest? Highest one is 24 here. Highest one is 24 here. Second one is 22. Third high, we have to arrange in descending order. Then 19, then 15, then 12. Arrange it in descending order. Arrange it in descending order. I hope this thing is clear to you. Here we have annual rainfall. Here we have annual rainfall. I hope this thing is clear to you. Now, we have to write m value. Okay, m means rank. Obviously, sir, you have arranged it. Now, obviously, this will have rank 1. This will have rank 2. This will have rank 3. This will have rank 4. And this will have rank 5. So these are the annual rainfalls which are arranged in descending order, and I have allotted them ranks. Can you do this thing? Yes, perfect. Yes, this is simple. You can easily do it. Now, what I have to do, I have to write the probability formula. Okay, obviously, we will use the most common one, which is VBull. Formula is m upon n plus 1. You can see this. Probability formula is m upon n plus 1. Okay. So we can write down the probabilities. We can also note down the time period. See, you all know that probability is inverse of return period. That simply means that t will be n plus 1 upon m. Okay. See, what formula we have used here in order to predict the rank, in order to predict the return period and probability, we have used VBull formula here. Okay. So can you guess? Can you tell me what is the probability? That this annual rainfall will be equaled or exceeded by 24? Sir, the probability of such kind of rainfall event will be m upon n plus 1. M is 1, n is 5. I hope you have understood that value of n is 5 in this case. So 5 plus 1 is 6. Okay. So the probability that rainfall value has equaled or exceeded 24 or is greater than equal to 24 is 1 by 6. How much? 1 by 6. Perfect. Similar. Perfect. Now, can you guess the return period? So return period will be 6. Just reverse of it. 6 upon 1. So such kind of rainfall event will take place out of 6 years. See, why 6 we are getting? Because we have taken very small data. I have already told you this data is not reliable. Why? Because we have taken small values. One mistake is there, but we don't have time for this thing. So obviously, if you have more time, you will take 50-year record. 50-year record will give you exact values or better results. Okay. We have a small data, so obviously we are not interested in this one. I hope this is very clear to you. So tell me, what is the probability? What is the probability that annual rainfall is greater than equal to 22 centimeter? You will say the answer will be 2 upon 6. And the return period will be 3, just opposite of it. What will the probability that my rainfall is greater than equal to 19? Sir, you will say 3 upon 6. And the return period will be 2. Sir, what is the probability that annual rainfall is greater than equal to 15, sir, the probability will be 4 by 6 and return period will be 1.5. Yes or no? Sir, what is the probability that rainfall event is greater than 12? Obviously, it's a lower event. Such kind of rainfall will happen every year because 12 is a smaller number. So such kind of rainfall will happen every year. Okay. So the probability will be 5 by 6 and return period will be 1.2. 1.2 means every year, okay, every year after another, you will see such kind of rainfall will take place. But it is a huge rainfall. So such kind of rainfall will take place once in 6 years. Once in 6 years. Yes or no? So I hope this concept is clear to you. So this concept is, you can say this is a concept of empirical formulas. This is the concept of empirical formula. With the help of empirical formula, sir, you can simply find the return period or probability of any event. Okay, and those events are already tabulated in the table. So what are the steps? Sir, steps are simple. The very first step is you have to arrange the past record in descending order. Sir, second step is that you have to give the ranks. Okay, you have to allot, sir, you have to allot m values. Sir, you have to allot m values from 1 to n. Sir, you have to allot m values from 1 to n in descending order. In descending order. Okay, allot values. See, we are giving ranks from 1 to n, 1, 2, 3, 4, 5 like this in descending order. Okay, in descending order. I hope you have understood the meaning of m. M is none other than rank. M is order or simply your rank. Then what is the third step? Sir, third step is that we have to use these empirical formulas. Okay, I can use Weibull formula, else I can use see, if I would have used California formula here, then the formula would have been P is equal to M upon N. In that case, what would have been the probability? Sir, in that case, the probability would have been 1 upon 5 because N is 5. No N plus 1. We have only N, 1 by 5. In second case, the probability would have been 2 by 5. Third case, 3 by 5. Fourth case, 4 by 5. Last case, 5 by 5, like this. Okay. So instead of Weibull formula, we could have also used California formula. Okay, and we could have also used Hazen formula. But yes, the most dominant and popular one is Weibull formula. Okay, the first one. The first one is the most popular one. I hope this is very, very clear to you. Now the third step is wait a second. Third step is that we have to calculate P or T, probability or return period. Okay, return period for the given data which is given in the table. Now the last step. Okay, now comes the last step, which is the most important. See, what if the data is not given to you in the question? Okay, let us assume I'm just taking an example. Like, let me write an example here with the help of which you will be able to understand. Tell me what will be the probability for event. Tell me what will be the probability for event. In which rainfall is exceeding 17 centimeter. Tell me, find the probability for event in which rainfall is exceeding 17 centimeters. Sir, 17 centimeter is not given in the table. Sir, if you would have asked that what will the probability if rainfall is exceeding 24 centimeter, I will directly would have answered that it will be 1 by 6. Yes or no? But this data is not given to me in the table. Okay, 24, 22, 19, 15, 12, I would have answered directly because that data is given to me in the table. Yes or no? So now how you will answer it? How you will find the probability of any kind of event? This was the ultimate goal. Today we have discussed that we are interested in finding the return period or probability of any event, be it in the given data or let it be not there. Okay, so how I will find it? Sir, obviously I have used the formula. Now see, 17 is lying between 19 and 15. Yes or no? You can guess it. 17 is lying between 19 and 15. Yes or no? You can see that 19 exceeding this 19 centimeter value has a probability of 3 by 6. And this 15 has a probability of 4 by 6. And you know that 17 is lying exactly in between them. 17 is lying exactly in between them. Yes. So we will interpolate. Yes. Perfect, Sushil. We will do it by interpolation method. Yes. So 19 is 3 by 6, 15 is 4 by 6. So obviously 17 is in between. So what comes between exactly 3 and 4? What comes exactly in between 3 and 4? Sir, it is 3.5. So the answer will be 3.5. Answer will be 3.5. I hope this thing is very, very clear to you. So I will write the answer will be, for probability greater than 17 centimeter, the answer is 3.5 by 6. Okay, 3.5 by 6 is nothing but 7 by 12. When you will divide it, you will get it 7 by 12 by interpolating. Okay, we have obtained simply by interpolating. Okay, from the given data. And if someone asks you like what is the time period, okay, what is the time period for such kind of event, for rainfall to exceed 17 centimeter? Okay, so time period will be just opposite of this, just reverse or reciprocal of this. It will be 12 by 7. Okay, 12 by 7 you can do and you will get the answer. Okay, it will be 12 by 7 year. 12 by 7 years. Okay, so I hope this is very, very clear to you. Perfect. Okay, I think the concept is clear to you. So, sir, what you are simply saying in the step 4, if they are interested in finding, okay, let me write here. If they are interested in finding any magnitude for any magnitude, probability and written period, if it is asked, how I will find? I will find by interpolating or extrapolating. So for any magnitude, we can find, P or T. For any magnitude, we can find P or T, okay, P or T by simply interpolating, or extrapolating. Sir, what is the meaning of extrapolating here? What is the meaning of extrapolating here? See, you need to understand one thing. See, interpolating is done when we have data in between. 17 is in between. Let us say 20. 20 is also in between. But what happens if this data is going outside this table? Let us say we are interested in finding the probability for rainfall event greater than 27 centimeter. So this 27 centimeter is above this 24. So this data is going beyond. So we have to do extrapolation. So whenever my data is going outside, I have to do extrapolation, and whenever my data is within the table, then I have to do interpolation. Okay, similar logic. Slope we have to do. Okay, we have to make slope equal, and then I will easily evaluate the answer. Okay, so I hope this thing is very, very clear to you. So step number 4 is simply find written period and probability for any magnitude. Okay, now I hope with the help of this concept, you are able to understand how I have written period here. Okay, so for this kind of design flood, how I will find written period, I have told you. Okay, how I will find written period, I have told you. If someone asks you like how you have found out, okay, how you have found out the written period, you will say, sir, firstly we have to obtain record for last 50 years. First I will do the analysis of this stream. Okay, I will find the discharge in these streams for the last 50 years. I will have the past record. Then I will arrange that past record in descending order. I will rank them. After ranking them, I will give the probabilities and written period. And if that event and if that magnitude is lying in that table, I will simply read out the values. And if that value is not lying in that table, okay, if it is somewhere in between or if it is lying outside, I will do interpolation or extrapolation. With the help of that, I will be able to determine the written period. I hope this is very, very clear to you. This is one of the very interesting topics of hydrology. Okay, when you will go in water resources department, these things you have to do practically as an engineer. So you need to understand that design flood being greater than equal to 500 meter cube per second, this thing will have a written period of 100 years. This we have determined with the help of a past record. Okay, we should have a huge past record for this stream or river, then we will be able to determine the written period. Okay, I've just assumed 100 years, but when you will solve, when you will have the past record of entire 50 years or 100 years, then you will be determining the written period for any kind of magnitude. Okay, if you want to find the written period for, let us say, design flood of 1000 meter cube per second, then written period would have been different. It would have been even more. And but how much more exactly, how much will be the value, that you will find with the help of that method which I have told you right now. So is this thing clear? Is this thing clear to you? Okay, with the help of an example I have told you. Okay, so this is it for today's lecture. Tell me if this thing is entirely clear to you. If any doubts are there, you can ask me. I will clarify it again. And in the next class, which will be the last, probably the last class of precipitation miscellaneous topics, we will discuss IDF curves. Okay, IDF curves, PMP, and world greater rainfall. These are very small topics, so we'll discuss them in the last class of precipitation. So I hope till here everything is very, very clear to you. If all the things are clear to you, tell me. Kindly comment everyone that if all the things are clear to you. Tell me everyone, tell me if the things are very, very clear to you. So we'll end our session today. So one more update that tomorrow there will be no class because tomorrow is Holi festival. So we will catch up day after tomorrow on 9th of March 2023. Okay. So tomorrow there will be no class. We will catch up on 9th of March. Till then, stay blessed, take care, stay happy, good night, and happy Holi to you.